नमस्कार दोस्तों. Imagine you are a coffee owner and you have just introduced a brand new espresso machine to your customer. Now, here is the thing. The machine manufacturer claims that it will give you the precise espresso in 27 seconds. But in reality, does it happen? Maybe it could take around 25 to 30 seconds in between. This variation in brewing time is likely a tiny mystery in your coffee making process. So here is the questions. What is the probability of getting espresso exactly in 27 seconds? This is where the continuous distribution probability comes into the picture. But why is this crucial? Well, my coffee loving friends, precision is the heart of the souls of every barista craft. It's about serving a perfect cup of coffee every time. The precision is matter. Understanding the probability empower you to maintain and delightful consistency. Today we are not only diving into the maths, but also we need to understand the daily magic happens in the continuous probability distributions. So let's get started. Continuous probability distribution is a powerful tool which describes the probability between continuous range of the values. Unlike discrete distributions where we deal with the specific and the separate outcome of the values. Continuous distributions variables which takes infinite values in between the range. To understand the continuous distributions, let's consider the height of the people in the populations. It's a classic example of a continuous distributions probabilities. If you see in this picture, probability density curves over the height of distributions. The curve represents the likelihood of someone's having a particular height. Notice that we cannot point at specific heights, but we can also talk about the probability of someone's falling within the certain range. Let's dive deeper with another example, commute times of busy city like Bangalore, right? Imagine we wanted to know someone's daily commute times fall in between 40 to 60 minutes in the Bangalore's traffic. Let's introduce a probability statement. You are working in a company as a HR manager and you wanted to know the employees spend 30 to 60 minutes in their daily commute. Continuous probability distribution help us to tackle these kind of questions. So let's jump into the analysis. So let's say someone's taking 30 to 35 minutes. The probability is 0.15, 35 to 40, 0.20. And 40 to 45 minutes, the probability is 0.30, 45 to 50, 0.20, and 50 to 60 minutes, probability is 0.15. Now, so let's calculate the cumulative probabilities, right? So, cumulative probabilities, let's say up to 35 minutes, the probability is 0.15. 40 minutes 0.35, 45 minutes 0.68, 50 minutes 0.85, and 60 minutes is 1, right? So in a cumulative probability, what we do, we just add each and every point. So from 30 to 35 we have a 0.15. From 35 to 40 we are taking we are just counting, we are just adding these two numbers, and similarly for the others, right? So we can get the cumulative probability, right? If we just draw this pattern, so if we just draw these tables into this graph, so you can see here is up to 30, and so 35, what we have 0.15, right? And for the 40 we have 3.5 will come here, so 3.5. For the 45, what we have 6.5, sorry, 0.65 comes here, so for 0.65, right? And for the 50, what we have 0.85, so 0.85, and for the 60 we have 1, right? So if we just draw this, connect all these dot which we have just calculated, if you see this, this is the 1 point, second point, third points, and for the 1. So this is a non-decreasing number, right? So this is a continuous probability distributions. If you can see, we can just draw this in a continuous probability distribution. So this is called a CDF, a continuous distribution function. We will talk about the CDF in a few minutes. I need to introduce another function called a PDF, probability density functions. So remember, when you talks about the continuous random variables, it's a infinite numbers of possibilities. Now let's see the core concept of probability density functions. Unlike in a discrete random variables, where we have a probability mass functions which assigns us specific values to the outcome. In PDF, we use a continuous random variable. This function defines the probability of entire range of the distributions functions. What makes PDF so fascinating is that the area under the curves, which represent the probabilities. The taller the curves, the higher the probabilities of the random variables falling within the specific intervals. Let's visualize this with the same example of commute time. Right? The PDF is actually a area under the curves which tells you the probability of the commute times for each and every employees, right? That area actually tells us the probability of commute times. So just take a pause, and I would say these kind of videos take a lot of times and efforts to create. So I firmly believe in the free educations, and I also learn a lot of things from the YouTubes. So if you like this video, these kind of videos, please do like, share and subscribe to this channel. It will give me a boost to create more contents on the educational side. So please like this video. Now go back to the video again. So if you want to find a probability that random employees spend between 30 to 60 minutes on their daily commute times, right? We look on the area of under this curve, right? So let's say x equal to 38. So if this will falls here, so this is actually a probability. So this area will tells you the probability of x equal to 38, right? So this shaded area is the basically a answer which we are looking for, and this is the actual probability which gives you the when we calculate with this PDF. So this probability density function, also called PDF, is like a mathematical magic wand that allow us to calculate the probabilities of continuous variables. It's a fundamental tool in statistics, data science and many other fields where we have to understand the uncertainty of the continuous variables. So we saw the PDF. Now we wanted to also understand the CDF in more details, and also we want to understand what is the relationship between this PDF and the CDF. So the continuous distribution function, also called a CDF, is a powerful tool that helps us to find the probability that random variables takes on the value less than or equal to the specific value. In simple terms, we also call the CDF tells us what is the probability that our variable is less than equal to any number like x, right? The CDF and the PDFs are interconnected, while the PDF provides the probability density at a specific point. The CDF integrate this probability density functions. The CDF integrate these densities and gives us the area up to that value. Let's say f of x on x equal to p of x is less than equal to x, where x is a random variable As we move from left to right along this CDF curve, we are summing up the probability and closer to the 100%. So the area is from 30 to 60. What would be the area? Area would be 1, right? So the range is lies between 0 to 1, right? So we will reach to the 100% of that continuous probability. I'm telling you guys, this CDF is invaluable in lot of applications. Reliable analysis, finance and quality control. There are a lot of application can be done around this. It will help us to make a decisions around the cumulative probabilities. There are two distributions which commonly occurs in this continuous variable. One is uniform distribution and another is a normal distributions. Let's dive into the uniform distributions. In a uniform distribution, all values with the specific range are equally likely to occur. It's like flipping a coin where heads and tails have an equal chance. But what makes uniform distribution so special? So in uniform distributions, the PDF is basically a constant. Yes. In uniform PDFs, all possible values have the same probabilities. So let's say you have a range of 0 to 10 and the range of, you have a range from 0 to 10. So in the uniform PDFs, the all possible values have a same probabilities. All possible values have the same probabilities. So let's say these are the area and all the so in uniform PDFs, all possible values have the same probabilities. So where x equal to 0 to 10. So you can say that 10 into h equal to 1. So where 10 is basically a 0 to 10. It's a range of the range of the random variables, and h is the height. So this is the h. So you can say that 10 multiplied by h equal to 1. So area from 0 to n. So range is 10, from 0 to 10. The area would be a 1. So area equal to 1, right? So what would be the h? So 1 by 10. So you can also say like a and b. So you can say h equal to 1 upon b minus a, right? In this case, so the value of the PDF for all the values between 0 to 1 is 0.1. Because in the uniform distributions, the PDF is fixed as a constant. So the PDF for all the possible x, which is 0.1. So let's take an example. So if I say find the cumulative probability where x equal to 0.5. So what you have to do, you have to find out the area of this, right? So this area, right? So this area equal to 0.1 into 0.5, which is 0.05. So we can say for x equal to 0.5, the cumulative probability will come 0.05. Similarly, let's say on this point, right? So what do you think on this point, what would be the cumulative probabilities for this uniform distributions, right? So let's calculate that x equal to 5, 0.1 into 0.5. What will happen? 0.5. So here, if you see, if you take this area from 0 to 5, what would be the area of this? 0.5. And for x equal to 10, what would be the 0.1 into 10 equal to 1. So till here you will get a area which is equal to 1. So as we can see in the uniform distributions, all the possible PDF is constant and value have the same probabilities. Uniform distribution can be used in a lot of applications. As you can see here, it can be used in random survey, quality control, lottery systems, randomized clinical trial, or election processes. Let's take an example of one of the applications and try to apply a uniform distribution on this example. So what could be the step one? So define a population, right? So where, just let's say defining a population to n, where n is representing the total number of individuals in the population. And step two, what we have to do, we have to assign a unique number for each and every number. So say 1 to n number we have, and you have to assign a unique number. So you can assign maybe Aadhaar card or number, or maybe a SSN, right? In step 3, what you have to do, you have to generate a random number for each and every populations, right? So use a random number generator that follows a unique number. So what we have to do, we have to generate for each and every number unique random numbers, right? So let's talk about the explanation part, how this can be done, right? So let's say government want to conduct a survey in a village with population of 500 house. So each house they will assign a unique number, say 1 to 500, right? In the step 3, what they will do, they will generate a random numbers to select the houses for the surveys. In that case, each and every residence has an equal chance on being chosen in for the surveys. Similarly, you can perform these kind of steps in a different use cases. This mathematical process underpins the fairness and impartialities of random surveys, making them valuable tools for the collection of unbiased data. So that's it from this video, and we will discuss normal distribution and the standard normal distribution in the next videos. So till then, bye bye.